Hello YouTube, this is Umoso3. So now we've already had about 1.5 or 2 lessons on linked lists, okay? And we've been trying to draw some similarities and distinctions between array lists and linked lists, right? And first we started with arrays. We've already known about arrays for a long time, but arrays have fixed length, and so you can't insert or remove elements from them. And we said, well, by the time we get to object-oriented programming, then we'll eventually be comfortable learning about array lists, right? And so an array list is like a resizable array. It's a dynamic array where you can insert or remove elements from the array list, right? But it's still totally legitimate to talk about index positions and elements occupying index positions. And so array lists are pretty similar to arrays, but you can grow and shrink them, right? And then in the previous 2 videos, we've talked about a linked list, okay? And a linked list is similar to an array list. You know, in the previous video, we saw that the linked list class has all of the same methods that the array list class did, okay? So for any linked list, you can find the size of it, you can see whether it's empty, you can add elements to it, you can retrieve elements from it, you can modify elements within it, you can remove elements from it, you can see if the list contains an element, you can find the index position of the first or the last occurrence of an element, or you can remove all elements from the linked list, okay? So same things that you can do with array lists, you can also do with linked lists. And we said the trade-off, the difference is in the geometry, the structure, because linked lists are better suited for inserting or removing elements within the list. But array lists are better for retrieving elements at particular index positions, or for manipulating or modifying or changing the values of elements at particular index positions. Okay, so for those kinds of tasks, you're better off with an array list. Okay, but if you're talking about inserting or removing elements at arbitrary positions, you're better off with a linked list, okay? And it's talking about time complexity, okay? So with array lists and linked lists, there's no difference between them if you're talking about adding an element to the end, okay? But with adding an element within, linked lists are gonna be better, okay? And so the reason why you should not completely forget about array lists is for getting and setting elements, right? Is that if you try to get an element at a particular index position, that's better with an array list. If you want to add or remove an element somewhere in the linked list, that's better with a linked list than an array list. Hopefully that's clear to you. But what we're going to do in this video, I want to talk a little bit more about linked lists and review the functionality, review these methods. But I also want to talk about 2 more topics. So I want to talk about another important class in Java called collections, okay? Actually, 2 more important classes in Java. So we're going to talk about the collections class and the iterator class. And so at this point, we've probably learned about 15 or 20 or 25 really important classes in Java, right? I think the first one was string, but then we looked at math and scanner and array lists, and then we looked at, you know, linked lists, then we looked at the file, you know, the file input output, you know, we had to have, you know, a file writer class and different things like that. But anyway, one of the things I might have forgotten to say in the previous video, remember when we were talking about array lists, we said that we need to import java.util.ArrayList. Every time you want to use a linked list, you need to import java.util.LinkedList. And I don't feel too horribly bad about not telling you that earlier, because you wouldn't have gotten very far in creating a linked list if you had tried to create a linked list without importing this class. It would probably give you a compile time error, right? We could compile it right now, and it's saying that we're going to have an error in the class. And it's going to say, what's a linked list? It's going to say, cannot find symbol linked list. That's the exact same error as it would have given you if you had tried creating an array list without importing the array list class. The solution that we said for array list is to import the array list class. Similarly, the solution is if you want to create a linked list, you need to import the linked list class. You say import java.util.LinkedList, and that needs to show up at the very top of your file, right? This is before even the class is declared, right? The class shows up in green in this IDE, and it just says egg tester. But before we even declare the class, we're importing these other important classes to use, okay? So we have array list, linked list, and these 2 are going to be the focus of this lesson, but I wanted to do a little bit more review first. We create 5 egg objects here, and remember we already created this egg class, so we've already seen this a couple of times now, right? Remember with the egg class, we have a constructor that just assigns 2 integer instance variables. The default one assigns them to 0. Pump A and pump B will increase A and B by 1 respectively. Resolve will return the result of A minus B for that particular instance. It's an instance method. And then we said that since egg is implementing the comparable interface, it needs to have a compareTo method, which accepts an object And what this compareTo method is, it's going to convert the object being passed into an egg in particular, and then we're going to compare two egg objects, right? The one that we're acting on, right? It's an instance method, so you're already acting on a particular egg, but then you're also passing in another egg. And so you're comparing those two eggs, and you're just looking at the result of the resolve method. So if my resolve method is bigger than your resolve method, if my a minus b results in a higher number than your a minus b, then we would say that me dot compareTo of you is a positive number. We would say I'm bigger than you, but hopefully that's clear to you. So with this egg test, we're going to add 5 egg objects, right? And you can see in the comment here, it looks like these are just integers that are going into this linked list. But remember, these are not eggs, right? The 21 and -3 and stuff, these are actually the results of the resolve function, okay? So if you called the resolve function on these egg objects within the basket linked list, right? If you do 42 minus 21, you would get 21, okay? If you do 3 minus 6, you would get -3. If you do 10 minus 10, you would get 0, okay? So these are the results of the resolve function called on the egg objects within the basket linked list. So hopefully that's clear to you. But we're going to add those 5 egg objects that we declared and initialized in these lines of code here. And then we could say system.out.println of basket.size. So hopefully you're clear that would return 5. But if you say system.out.println of basket.isEmpty, that would return false, because the only time that a linked list would be empty is either at the beginning, or if you cleared all the elements from it, or if you one by one individually removed each of the elements from it. But anyway, then you could create a new egg object, and you could say basket.set of 0 p. So this would set the element at index position 0 to instead of what was there. But now what we're going to do is we're going to have this egg object, okay? So the result of the resolve method, if you call the resolve method on index position 0 within the linked list, you would no longer get 21, which is 42 minus 21. You would get 7, which is 12 minus 5, right? And then we say basket.remove of 4, okay? And so basically what we saw in the previous video is, what if you were talking about an array list or linked list of integers, and you had, an integer 4 in that linked list, and you said, list.remove of 4. Would it remove the 4, or would it remove the element at index position 4? And it would remove the element at index position 4. So this would remove the element at index position 4. And so therefore there would be no 5th element, right? You wouldn't be able to call resolve on the 5th element. And that's why you wouldn't be able to get a -8, because there's nothing to resolve, right? In the fifth element, there's only 4 elements now. And that's why if you call system.out.println of basket.size, now you would get 4 for the output instead of 5, which is what we got up here, right? So hopefully that's clear to you. In this video, we have 2 new topics to talk about. So there's another class that we want to be familiar with, right? We've been getting familiar with, remember we got familiar a few lessons ago with the thread class. Remember we said we talked about threading. So there's so many darn classes we've learned about in Java: thread and scanner and math and integer and Boolean. There's so many damn classes, right? But there's also one called collections. And so I want to talk about the collections class. We've already learned about different ways to sort an array or an array list or a linked list, right? Now you can sort linked lists, right? And we said there are 3 approaches to doing it. You can either use a bubble sort, which is pretty easy to write code for, but it's pretty inefficient for Java. Or you could use an insertion sort or a selection sort, which are more efficient, but they're a little bit more work. They're slightly more lines of code for the programmer to write, okay? And so that's the trade-off to make, but obviously you would want to probably make a slightly more complicated program if it were more efficient for the computer, right? That would probably be the goal. But anyway, we've already talked about 3 sorting algorithms, but what we had to do is we had to implement them manually, and we had to figure out the lines of code that we would need to write in order to get those sorting algorithms to work. It turns out that you can actually sort an array list or linked list by simply calling on a sort static method, which belongs to the collections class. So let me show you what I mean by that. What we're going to do is we're going to open up blackhole.com. I've been using Google a lot recently, but let me go back to being a man of my word. And then what you can do is you can look up the API for the collections class. So you're just going to type in collections Java API, and it should be the first link that appears. This class contains exclusively of static methods. Literally, there are no instance methods, okay? So you would not create a collections instance. You wouldn't create a collections object and do things with it you would just use static methods from the collections class, right? Just like with the math class. Remember with the math class, we didn't create math objects. We didn't, oh, math A, math B, math C, right? We just said math.square root or math.cosine, right? Those are static methods, okay? And so these are all static methods. Every single one of these methods says static on it, right? But it says operate on or return collections, right? Think ArrayList or LinkedList. It's collections of elements, okay? And it operates on collections or wrappers, which return a new collection backed by a specific collection. So anyway, this will probably get a little bit more wordy than you're interested in. But we're going to be looking at the sort function, or the sort method. Okay, so if you say collections.sort of list, okay, and so basically what it would do is it would return another list where the elements are sorted, okay? And you might be wondering what algorithm does Java use to actually sort it? Does it do bubble sort? Well, probably not. Probably doesn't do bubble sort because we said that bubble sort is not very efficient, especially for large lists, okay? But basically, maybe the API would tell you. So it would say the implementation was adapted from Tim Peters list sort, okay? It's called Tim sort, okay? And so I guess this is technically an algorithm, right? And it tells you exactly what Tim sort does, right? But presumably Tim sort would be a little bit more efficient than insertion sort or bubble sort. So hopefully that's clear to you. But anyway, the whole goal is to have efficient algorithms. So anyway, the point, what I'm trying to say is that if we go back to the egg tester, remember, we can operate the resolve method. We can call the resolve method and get an integer for any of these egg objects, right? We have this method called resolve, which acts on an egg object and returns an int, right? It returns the difference between those two instance variables for that particular instance of the egg class. Okay, but what we're going to do now is we're going to sort the baskets. We're going to say collections.sort of basket. Okay, and so basically what this would do is it's going to sort the list using the compareTo method, right? And so basically, how do we compare two egg objects? Well, we said we would look at the resolve method. And so what we're going to want to do is we're going to have a list of egg objects where when we call the resolve method, we're going to want to see the results of the resolve method be in ascending order. So we're going to want to see -3 on one line and then 0 and then 4 and then 7, because that would be the ascending order of the results of the resolve function. And that's literally how we sorted the list, right? It's stacking the egg objects, but it's doing that by the resolve method. Okay, so therefore, presumably, if we call the resolve method, certainly those results should be ascending, because that's how we said we wanted to sort the egg objects, by the resolve method. So anyway, so hopefully we're going to get the -3, 0, 4, 7 on the console. So now, and then we're going to print the word MIN in capital letters. But hopefully these are going to be the last 4 things we see printed on the console before the capital min, before the capital MIN. So now we can go ahead and, compare what we were predicting by talking through all this by what we actually end up getting on the console. So now if we go ahead and run it, we can sort of, let me try to pull up both of these things at the same time, right? So you could be looking at, we saw 5 and false. So these were these 2 lines of code, right? And then we have basically 4, and then 4, this was from this basket.size. And then we have -3, 0, 4, and 7. So hopefully that's clear to you. And then there's also collections.min of collection and collections.max of collection. So min and max are also static methods. So you call them on collections. And basically you pass in an ArrayList or a LinkedList. And what it'll do is it'll return the maximum or minimum elements of that ArrayList or LinkedList. And that works with any object that's sortable, right? So obviously it works with integers and doubles. It also works with strings. We would say that strings are sortable according to how they appear in the dictionary, according to lexicographically how they would appear, right? So we would say that w.compareTo of A is greater than 0, right? We would say W is bigger than A because it appears later on in the dictionary, right? But what we would do is we'd say collections.min of basket, and you can go ahead and look at the documentation for this, right? So we could go ahead and look at min. So it would be a static method, and you'd have to be a little bit careful about which of these overloaded methods you were talking about, but we're just gonna pass in a collection. So it's gonna be this one, collections.min of, and then all this stuff, this would just be like an ArrayList or a LinkedList. And it just returns the minimum element, okay? And so according to our compareTo method, remember, we can make any objects, we can make any class sortable. And according to our compareTo method that we wrote in our egg class, we said that, you know, one egg is less than another egg if the first egg has a lower resolve method, right? So we want the minimum resolve. We want the minimum result of resolve, and that's why you get -3. So it says print egg of Collections.min of basket. Well, what does the print egg method do? Well, this is a static method that belongs to this class, and it accepts an egg object and it returns a string. So if you feed an egg object into print egg, it returns a string which says this egg has a resolution of, and then t dot resolves, the results of the resolve method. And that's why it says min, this egg has a resolution of -3, because Collections.min of basket would return the egg object whose resolve is -3, right? So hopefully that's clear to you, right? And then this egg has a resolution of 7, right? Because Collections.max of basket would return the egg object whose resolve method returns 7. So hopefully that's clear to you. We only have a few minutes left. I want to talk about something called an iterator. Okay, so basically an iterator is basically an object that is capable of iterating through an array list or a linked list. Okay, so anytime you create an array list or a linked list, what you can do is you can call the .iterator instance, the .iterator function on it. And it's an instance method that belongs to the list class. We haven't talked about a list class. We've only talked about an array list class and a linked list class. An array list and a linked list are both subclasses of a class called list. Okay, so list is a superclass, and we talked about inheritance, right? And we said that any methods in a superclass are going to be inherited or going to come down into the subclass unless the subclass overrides it, right? Unless the subclass provides its own definition for it. So what you could do if you were, you know, if you were curious enough, what you could do is you could go ahead. Let's look at the list class. So this is the list class, and it's a super class of linked lists, right? So you could get here from linked list, but there's an iterator method. Okay, you'd say basically you call the iterator on an array list or linked list, and it returns an iterator over elements in the list in proper sequence. So let me show you what I mean by that. The first thing you need to do is you need to say import java.util.iterator. So just like what we were saying with collections, right? If we want to say collections.sort of an array list or linked list, or collections.min of an array list or linked list, or collections.max of an array list or linked list, you need to import java.util.collections. In order to use iterators, you need to say import java.util.iterator. You need to make sure that's at the top of your class. And then what you're going to do is you're going to say iterator of type, and then it's going to be the same object type as whatever was in your array list or linked list. So if your array list or linked list had integer objects in it, then it would be an iterator of type integer. If your array list or linked list had objects of type egg in it, then your iterator would be of type egg. And then you need to go ahead and name it. So you would say iterator of type egg, and you can call it whatever you want. Call it listParse equals, and then you call it on an array list or linked list. So you'd say basket.iterator. Okay, and then what we're going to do is we're going to say while, and then what you're going to do is you would put this in the context of a while loop. This is how you use an iterator. So you create an iterator object, right? So you create an iterator object based on your array list or linked list, and then what you would do is you would say while. So this is the architecture for it. So you would say while of iterator.hasNext. Okay, so there's a hasNext method, kind of like if you remember when we were talking about reading files, right? And we had to call it hasNext method, right? Because we have to go ahead and keep reading the file every time there's a next line in the file to read. And that's kind of like what the iterator is doing. So it's an iterator is responsible for parsing through an array list or linked list in the context of a while loop. Okay, that's how you want to think of it. But you would say while listParse.hasNext, and then what you would do is you would basically go ahead and assign, basically you would say that the iterator.next, so now .next, if you call .next on the iterator, that will return the next element in that array list or linked list that the iterator is based on. Okay, so let me tell you what I mean. So you create an array list or linked list, right? You give elements to it, and then you import. So you import array list or linked list, and then you import an iterator, right? And then you create an array list or linked list, you add elements to it, and then you create an iterator of the same type as the array list or linked list, and then you say equals array list or linked list dot iterator, and then you say while that iterator dot has next, and then within the while loop, you would just say system.out.println of iterator.next. That's sort of what we're doing here we're going to pass in that egg object. We're going to pass in each of the next egg objects into the print egg, and it's going to tell us this egg has a resolution of, and then whatever the resolution of that egg is. And so that's why we were able to iterate through the 4 eggs and do the print egg method on each of them. So hopefully that's clear to you, and we'll review in the next video. From myList.iterator, thanks for watching, and please subscribe.